Hello, I'm Nullen, and in this series we'll cover a quick intro to Till. In this video, I'll be explaining what Till is and how it can be used to create smart contracts on Algorand. Put simply, Till is the human-readable representation of the bytecode that runs on the Algorand virtual machine, also known as the AVM. A Till smart contract will only be successful if it ends execution with a single, non-zero unsigned integer on the stack. Ending evaluation with multiple values on the stack, a 0 or a byte string will result in a failure, and the AVM will reject the transaction without charging a fee to the sender. Till can be written by hand, although this is best suited for those who have a background in computer science or are familiar with low-level software development. With that said, Till can also be produced by higher-level languages. Two popular examples of this are PyTill and Reach. Both options allow you to compile out Till smart contracts, but with the advantage of writing more traditional programming-esque syntax. Till is currently made up of roughly 167 opcodes and has been increasing with almost every update. If you're wondering where the name Till came from, it's actually an acronym of Transaction Execution Approval Language. The two primary uses of Till are smart contracts and smart signatures. Smart contracts are applications which are deployed on-chain by another account. All smart contracts are made up of two separate but required parts, the approval program and the clear state program, which I'll cover in more detail in the next video. Smart contracts are called by issuing application call transactions. These are different from payment or asset transfer transactions, which cannot invoke a smart contract by themselves. A smart contract can be stateful, reading and writing up to 64 global and 16 local key value pairs. Since version 5, all smart contracts have their own associated account, allowing for a smart contract to act as a programmable escrow account. Smart contracts can also issue inner transactions to other accounts or other smart contracts. This includes deploying their own smart contracts. I've marked smart signatures as an advanced topic purely because it's difficult for newcomers to know about all the different security checks they must make before using them, and for most needs, a smart contract will work just as well. Smart signatures are not stored in the ledger like smart contracts. Instead, they're a single program that's kept off-chain and are included with a transaction, just like a signature, before then being sent to a node for evaluation and inclusion in a block. Smart signatures are stateless during their evaluation, meaning they cannot look up global or local state. Instead, they must look at their own transaction details or the details of other transactions within their group. I will add, however, that a smart signature may opt into a smart contract and hold local state storage. This is because, much like a smart contract, all smart signatures have their own account. Additionally, a smart signature can be signed by another account to create a delegate signature, which has authority over the signer's account. Here are two Till examples, one demonstrating a simple counter smart contract, which increments a global counter on each call. The other one shows a smart signature which will opt in to any Algorand standard asset you want, but it cannot do anything else. Thank you very much for watching, and until next time, have a great day.